Hello audience, welcome to watch a video that explains the tube paradigms, symbolic and systemic, both theoretically and practically. This video starts from software analysis of IT industry based on the symbolic approach, my dissertation from the years 2003 to 2008, and it ends to a large systemic approach. This topic has been given me skills and knowledge during the latest 15 years. I am Metayliopisto from Metayliopisto forum. The thesis Symbolic Analysis and Atomistic Model as a program conference in methodology gave me a starting point, a kick to analyze computer semantics and behavior as well as cognition. The two keywords here are symbolic and system, systemic, symbol and system. I've had a pleasure to find out what these important keywords mean. So I've decided to compare keywords to berries that you need to know in order to understand the complex software industry and, of course, society. Berries have their color and symbolic is here red and systemic is black. Symbolic means indirect expression and is often attached to goals, behavior and reasoning. The term subsymbolic is usually associated with neural networks through brain research. Systemic intelligence is not a well-defined concept, but it means intelligent behavior in the world of systems. And this video is a unique story of learning and self-organization with a promise to handle and explain anything. Before I started this work, the word symbol was just a word among other words. Taking the symbol as a research object gave me a rise to the Alice in Wonderland phenomenon in my mind, because even dreams are systems and symbolic. Grammar technology has been and is still one of the most necessary research topics in information technology, with its remarkable phases. The concept system caused a different kind of affair in my mind than symbol, but it's not less than the symbol. The phrase "everything is a system" is repeated in hundreds of research publications once again, and systems science is a research area devoted to it, whose effects reach everywhere. A large number of citizens think that they understand the system very well, but in contrast, for example, climate change has been approached from where the fence is lowest, which can cause great damage to nature and economy and the structures of society. One-eyedness is never good. Instead of speaking about carbon dioxide and such kind of taxation rules, we should speak about Earth systems science, because this is a holistic approach to the world. There are roots how information and energy and is going on in nature here in this picture. About nature, this picture shows ocean. Information is captured from Wikipedia here. The topic ocean literature has been adopted about 20 years ago, and it extended into Earth systems literature 2008, and later wide into cybernetic literature to understand influences, which is the kernel of cybernetics, and later it has been adopted into the system science societies. There are several of them here, and this is the website of system literature here, and it's possible to get information more about that. But then I will show what is systemic approach to ocean. This is your system literature picture here. This traditional study, ocean literature, earth science and atomistic science. But in extending this approach into the systemic world, there are system literature principles which include social systems, biology and ecology, physical and chemical systems. And this is the holistic approach instead of those reductionist approaches earlier. Ocean literature is defined here. It's wide-ranging, collaborative and decentralized effort by scientists and others to create a more ocean literature society. And definition for ocean is here from Wikipedia, and there is contents. Number 1 is terminology, number 2 is natural history, and 3 is geography, and 4 is physics. And it's possible to create atomistic model for ocean, very small model here, from the contents. There are 1 and 2, there are terminology and natural history, and the most theoretical part here is geography. It's number 3, and so on. This is environment here, physical properties, and so on. And it's possible to make a simulation model for ocean starting from this small picture, small diagram. Then this is a set of captures created by DuckDuckGo search engine, and this is a meta search engine here which has made a combination of these kind of roles. For example, number 1 here, its origin of information for oceans is here, and the most theoretical part is here, and so on. And those pictures are symbolic, as we see, and in those here there are 8 roles here, and all of them are systems. It's possible to make any of these roles into the center of this picture and to get more and more information, so that information can be text or drawings or videos on news or maps or so on, depending on the search engine that we will select here. And those kind of symbols, visual symbols, are very efficient for anybody to start to understand anything, any other than oceans. For example, society. The principle here is to get more and more information. For example, number 3 is research, ocean geography, and inside geography there are other fields, so that this picture is extended. And this is new kind of learning. It's a parallel learning, parallel search instead of deep search, which is going more efficiently into deep details. This kind of principle gives us better internal skills. And the advantages of this picture and this method is that it contains analysis and synthesis and planning together in the same method. This picture comes from my doctoral thesis. It's about 15 years ago. It's a book in Amazon created from that thesis later. And there are drawings, many drawings, about 100 drawings in this picture. This is a traditional horse-saw picture. It shows how information as source code goes this horse-saw, left lower side, and it goes to high level for modifications, transformation, and it goes then to the right lower side. This source code also there. And there are pictures about architecture and processes of this thesis and Wikipedia pages. There are some articles written about this methodology and its new approach to handle source code as symbolic analysis methods. This architecture of this work in software side, object-oriented hierarchies, and its own atomistic semantics. It's in the center of other semantics of source code there. There are about 20 different subgoals in this thesis, and it compares symbolic analysis with static and dynamic analysis. All of them have benefits and drawbacks. It emphasizes hybrid learning, understanding different kinds of learning styles, and this article speaks about static, dynamic, and symbolic analysis all together as my work here. And there are symbolic paths to be executed. For example, to write software for virus detection and virus removing. This is a cover of my thesis. It's an atomistic model resembling those pictures here also. These are concrete subgoals of this thesis. This is a very important research topic also, software testing and debugging and analysis and making corrections and maintenance together. There are some solutions in this thesis. The processes go from grammar tools into possible changes, and there is conversion from Java to Symbolic language. It's a new language for this purpose. There are some abstractions inside of the tool and some articles. So basic research level work. Each symbol in code is a Turing machine. It's a discovery. Source code analysis process is a navigator. It navigates source code. There is ontology, grammar, epistemology, and so on. Then combining systemic and symbolic approaches, here backcasting from today into the time before the work. This site, WordPress site, is named Symbol-Driven Engineering, SDE. It's written by me, and there are about 100 articles about computer science, core computer science, and those definitions are from the thesis, as they were earlier, and drawing as a framework for this work. It defines a planning tool, software planning tool, maintenance tool. It includes grammar, modelware, knowledgeware, and simulationware. There are conceptual spaces, also called technological spaces, and there are maintenance human and computer tasks there between those wares. And this model is the same as I showed here in the ocean page. Ocean literature is a system literature. It's a way to understand anything. It includes purpose, theory, environment, innovation, paradigm, evaluation, solutions, implementation, and finally the feedback. And this model can be adapted, connected into my earlier work, which is here. So we have here transformation framework before the work and transformation framework after the work here. The purpose is to find a route from H1 to H2. It goes through this kind of sub-goals: B, hardware ontology, and software ontology, and E, modelware, and E, this is a grammarware part. It opens the code, and then there are C, D, and F. Knowledgeware and maintenanceware, maintenance part, and simulation. How to simulate code? How does the tool work? This is a universal machine, also universal planning tool in order to adapt those kind of abstract rules. Then about my later work, symbolic analysis and systemic analysis. This is a snapshot about Google search. There are my books, Meta Science, Super Science, and so on. And there's also 3 books about intelligence, responsible artificial intelligence. The purpose of this year is to create a book about theory of everything. Comparing those approaches, symbolic and systemic here, both are by nature object-oriented because they are focused and they are cognitive. They can work both in man's hand or machine and by machine. The books of my approach here, for example, this is innovation books, systemic innovation book, a platform for innovation. And the term symbolic system, it's not new. There are about 9,000 results in semantic scholar database, and the most cited there is language and culture. It's written about 25 years ago. So this research topic, symbolic system, is very promising. Language is a symbolic system for communication, it's said in this picture here. And this is a snapshot about Stanford University. Symbolic system faculty team. It's a common topic for 7 faculties in this university, which is very famous. The symbolic system is a language, as we can see here. Symbols can be words, images, body language, sound, etc. Every kind of express anything. They are symbols. And this symbol here is from systemic approach to source code. The red color, it is symbolic code. It can be translated from one approach from language into another language, and then systemic approach is a transformation from basic architecture here into desired architecture. Systemicity can be seen everywhere in hardware and software. There are about 2 million articles in Semantic Scholar about system and IT technology. It's a very, very popular topic and combination. The most traditional system approach into computer technology is von Neumann computer architecture. It has input and output and process, as well as control unit and artificial arithmetic logic unit. But nowadays this picture has been changed. This picture is about information system, which is more modern. It includes several kinds of connections and utilities and networks and so on. The next picture is about satellite networks, which are also systemic. And the last one here is about inside our computer integrated circuit, where the connections can be very, very small, nanometer level. And this principle about system literacy, it can be used in every level of this wide approach. And how to plan this kind of work, for example, how to plan computer networks, satellite networks, and information systems. This is a approach about from Andres Hierniemi. He has drawn this picture. And these kind of ellipses there are system specific. For example, interactive planning, optimization, reflective practice, critical systems heuristics, system dynamics, and soft systems methodology, which is here the first methodology to use in order to understand what is picture vision and mission and worldviews of the work. And this understanding model here supports holistic thinking, understanding limits and environment, interaction with environment, dynamics and behavior and so on. It's possible to use this kind of model for innovation platforms. Then systems theory in general. It's mental level, not physical level. It's like metaphysics, not physics. System theory aims to explain and develop hypotheses regarding such properties that arise in complex systems. And such a phenomenon is called an emergent pattern of behavior. It causes emergence. We start from beliefs and make much more work and study, and it can create emergence in order to begin a new area, new way of thinking. It can be used for many kind of purposes, public purposes, perspectives, politics, and financial economy, social technology approaches, and so on. Almost everywhere. One good example is here socio-technical system. Its principle is here for complex environments. And then is a knowledge model, Nonaka-Takeuchi model. It includes 4 different kind of approach is socialization, externalization, combination, and internalization. This is a spiral, like in my picture about ocean literature. It starts from a very small amount of information and it gives more and more information into the system and project. This picture is adaptive cycle of systems. This starts from environment into social systems, capital, money, and risk perception and actions. And those kind of systems are recursive. Inside one system there are lower cycles and lower cycles, and they are working altogether interactively in order to make oneself steady and steady, adaptive, and to survive, to make them sustainable. Information technology is specific hierarchy. It's very important. This is not a hierarchy. This is traditional computer technology with its 4 parts: accounting, human resources, sales, research, and development. And this shows how systems cannot be made today because they are not networked. And this is a organization model which is not correct. Its framework is not working because there are barriers there. It's not possible to see or communicate with this kind of work. But this is an optimal way to understand large topics. This is from the dissertation of Velikovsky. The theory, meta theory, is named Storyality. It's for video study, which kind of movies are working good and which have failed. But when we replace this topic by global IT industry, it's possible to plan global information technology infrastructure efficiently by planning theories, getting more and more information about theories, and as well as the same for practices, methods, concrete methods. And those kind of changes, transformation from science to mathematics and practice, they must be planned in order to get the infrastructure working. This picture is from hierarchy. It concludes the levels 0, 1, 2, and 3, and several kind of organizations. It's not hierarchy but hierarchy, which can be adaptive and change according to the specific topics and situations. This is another picture about hierarchy. In the center there is one task, and in the largest part here is environment, and it includes more and more jobs and tasks and duties in macro level compared with micro level. Some other pictures about IT infrastructure and this systematic behavior. These are a picture about hierarchy of social systems extending to cosmos. Those kind of pictures have been adopted by Google search, picture search, from Piero Mella book named The Holonic Revolution. Those kind of pictures are very good and expressive, and it's possible to understand what is hierarchy and how it is revolutionary. in management and organization and in understanding nature and so on. Industry is developing so that we are now in the level of Industry 5.0. It includes human robotic collaboration, cognitive systems, customization, and so on. And the earlier phase here, 4.0, it includes cyber-physical systems. And system is very efficient and important topic here. How to understand modern industry and working. Cognitive systems is here in both of those approaches, symbolic and systemic. And this is finally the last one. The conclusion. This video is an example of expertise that has been not been made public yet. There will be immense needs for a new kind of system intelligence in our complicated world. And those kind of symbols, symbol system, meta, cyber, and para, and they are forming a new kind of language with its prefixes and postfixes and infixes. Cyber symbol is their red color and system is their black color. And we will continue for this work. In order to get a book, Theory of Everything, which is as expressive as possible. Seen again. Best regards.